So as I promised you, in this next short recording, I will explain you once more how to apply the altitude corrections to the instrument height you obtained with your sextant when you're observing a celestial body. Okay, voilà. So as you all know, in the front of your nautical almanac, on the front pages of your nautical almanac, you find the altitude correction tables. On the one side, you have the corrections for observations of 10 up to 90 degrees, and on the other side, you have observations for 10 up to 10 degrees. Okay, we'll focus on this side, 10 up to 90 degrees. In this list, you find the corrections for the sun and the stars and the planets. Okay, voilà. So, excuse me. I will explain this to you via this. Excuse me. Via this first example of doing altitude corrections for the sun. Okay. The idea is that first of all, what you read on your sextant is your sextant height or the instrument height. Okay. On this, you have to apply the index error, shortened by I. Okay. The index error is either on the arc or off the arc. As I already told you, when it's on the arc, the correction is negative. When it's off the arc, the correction is positive. Okay. Voilà. So you apply the index error. This is always given in the exercises. Okay. So you apply the index error to obtain the observed altitude. Okay. To the observed altitude, you have to apply the dip. Okay. The dip is a correction for the height of the eye. Okay. The dip is always negative, because your observation will be too big because you are at an elevated position doing the observation. Okay, so this depends on the height of the eye, which is also always given in the exercise. Okay, where can you find the dip correction? Well, for the sun and the stars and the planets, you can find the dip correction here in this column. Okay, so let's say A is the height of the eye. Let's say that it's 10 meters, and it's somewhere in between 9.9 and 10.3, and this gives you then a dip correction, which is always negative, of minus 5.6. So the dip correction will be minus 5.6. Okay. Okay. Then, if you apply the dip correction to your observed altitude, this gives you again the apparent altitude. Okay. So as I told you, when you apply the dip correction to your observed altitude, you obtain the apparent altitude. Okay, and then to the apparent altitude, you have to apply the main correction, which is actually aggregate correction for refraction, semi-diameter, and parallax error. Okay, in this main correction, which you can find in the first pages of your nautical almanac, all of these effects that you can see here are included. Okay, and the only difference is that they make a difference between observations for lower limb and observations for upper limb. Okay, again, I will go to the correction table page, and for the sun here, you can see they make a difference between the period of observation. Either you do an observation between October and March, or between April and September. And then you apply the correction on the apparent altitude. Okay, you know whether you've done an observation for either the lower limb or the upper limb, and then depending on the value for your apparent altitude, you obtain a correction. So let's say if my apparent altitude would be 19 degrees 40 or something, it would be in between these two values here, and then my correction for lower limb would be plus 13.6. Okay? The corrections for lower limb are always positive because the observation that you see, or the height that you see on your sextant will be too low. Okay, so you have to add this correction. Okay, if you do an observation for the upper limb, the altitude you see on your sextant will be too big, so you need to subtract the correction. Okay, that's why observations or corrections for upper limb are always negative. Okay, voilà. So that's actually what you can consider as correction C1 for the sun. Okay, then C2 for the sun could be when you are doing observations in non-standard atmospherical conditions. So if you deviate from these standard conditions, 10 degrees Celsius and 1010 millibars. Okay, if this could be then considered as C2 for the sun. Okay, if you do not deviate from these standard atmospheric conditions, you just leave it at the side, so there will be no C2. Okay, but let's say how to apply this table, how to use this table. And if you have, let's say, a temperature of 20 degrees, something like this, and 1030 millibars or something, then you have the point here, and you go down in this H column, and then you here, depending on your apparent altitude, let's say your apparent altitude is 18 degrees, then you obtain here in this column a correction which will be plus 0.1. Okay, but in most cases this will also be given in the exercise. Okay, if nothing is given, then you will be on standard atmospherical conditions. If you deviate from these standard atmospherical conditions, it will be mentioned in the exercise. Okay, so and that's then all the corrections you need to apply for the sun. Okay, so you apply C1 and maybe C2 to obtain a true altitude. Okay, voila, so the main correction and then possibly an additional correction for non-standard atmospherical conditions. This could be named C1, this could be named C2, and then you obtain a true altitude, which is actually the altitude that you will compare with your calculated altitude, and that will give you a delta H, being the intercept. Okay, but I guess you have understood that by now. Okay, then for the stars, this is actually basically the same principle. Again, you have your sextant height, you apply the index error, this gives the observed altitude, then you apply the dip, which gives you the apparent altitude, and then again the main correction, which you can call C1, and the additional correction for non-standard atmospherical conditions. Okay, no, it's not that one, it's this one here, excuse me, the main correction and the correction for non-standard atmospherical conditions. Okay, I will show you this again in the list of the Nautical Almanac, the correction table of the Nautical Almanac. For stars and planets, you can find the corrections here. It's clearly mentioned, so it's not too difficult. And then depending on your apparent altitude, if you have an apparent altitude of 18.40 or something, this will give you a correction of minus 2.8. Okay, that's what is mentioned here. Okay, so that can be considered as your C1 for stars. Then for the stars and for planets, excuse me, Venus and Mars, there is a second correction, very small correction, depending on when you are doing your observation. Okay, but this is only for Venus and Mars. Okay, so this could be called then maybe C2 or whatever. For me, I actually don't care what you call it, C1 or C200 or C33, I don't know, as long as you apply all these corrections. Okay, so C1 and C2, if you want to call it like that, for stars and planets, and then again, maybe the C3 for non-standard atmospherical conditions. Okay, only if they are given in the exercise. Okay, and this will give you then the complete true altitude. Let's say that this is then C3, and this will give you then the C1, C2, C3, whatever. This will give you the true altitude for the star or the planet. Okay, voila. Then for the moon, this is actually slightly different. The same start. You start with your sextant altitude or height. You apply the index error. Then you have the observed altitude. Okay, again you apply the dip, which gives you the apparent altitude. And it's actually always to the apparent altitude that you have to apply the corrections you can find in a Nautical Almanac. Okay, as I told you, the corrections for the sun and the stars can be found in the first pages of your Nautical Almanac. The corrections for the moon, that's a different table you have to use. They can be found more to the back of your Nautical Almanac. Okay, you have a main correction which is subdivided into two parts. Part 1 is for refraction, semi-diameter, parallax, and part 2 is for variations in semi-diameter and parallax depending on the horizontal parallax. Okay, so when you do your observation, you will always have to extract the horizontal parallax from the daily pages. Okay, well, I already explained this to you before. The horizontal parallax appears on the daily pages of the Nautical Almanac next to the GHA, the declination, the decorrection, and next to that you can find the horizontal parallax. Okay. Now I will show you the table for altitude corrections that you should use for the moon. This is that one here. It can be found at the back side of the Nautical Almanac, but also on the yellow pages. There is one yellow page somewhere also in the beginning of your Nautical Almanac that you can tear out of the booklet. Well, and in this yellow page, you can also find the altitude corrections for the moon. Okay, altitude corrections are always to be applied to the apparent altitude. Okay, and this is always clearly mentioned in your book. So even in the altitude correction tables for the sun and the moon, you know that you have to apply it to the apparent altitude, which is mentioned there. Then the apparent altitude, I make it a little bit larger for you. What is that apparent altitude? Maybe you have accidentally forgotten this at the exam. Well, take your reading glasses and read what is printed out just in front of you. The apparent altitude is the sextant altitude corrected for index error and dip. Okay, so that's what I've been telling you. You have your instrument height, you apply the index correction, this will give you the observed altitude. Then you apply the dip, so index error and dip, and this gives me then my apparent altitude. And it's to this altitude that you have to apply all these C1, C2, C3, C whatever to obtain the altitude. Okay, so back to the moon. The altitude corrections for the moon are to be applied on the apparent altitude. Let's say we have an apparent altitude of, I will say here, 18 degrees. Then, or 18 degrees 30, that's maybe a better example. So I know that's between 15 and 90 degrees. So I go down this page until I bump into number 18. And then on the left-hand side column, I take the 30 minutes, yeah, and then this will give me then a correction of 62.5. That is part 1 of the correction, okay, or maybe C1, okay. Then you go down this same column and you decide, or you know, if you have done an observation of either the lower limb or the upper limb, okay. So you choose here your column. Let's say we did an observation of the lower limb, and I follow in this column, and let's say my horizontal parallax was 58.5. And again, it's not difficult. I find the intersection between these two lines, and this gives me then part 2 of the correction, which can be considered as C2, which is 0. Okay. Now, I wonder, what should I do with these two corrections? Are they to be added or subtracted? I know they are to be added, but again, if you have accidentally forgotten this at the examination, take again your reading glasses and read what is mentioned here. All corrections are to be added to the apparent altitude. And again, what is the apparent altitude? It's the sextant altitude corrected for index error and dip. Okay, so I have to add these two corrections. So I take 62.5 plus 6.0, this gives me 68.5 plus 68.5, okay, to be added to my apparent altitude, okay. But there is always a but, and in this case they say, but 30 minutes are to be subtracted from the altitude of the upper limb, okay. If you do an observation of the upper limb, with your sextant, you place the upper limb of the moon on the horizon. This means that you will have a reading on your sextant which is too high, so you will have to subtract 30 minutes in order to correct this error. Okay, so this can be then maybe your C3, and then additionally C4 can be for non-standard atmospheric conditions. Okay, so these are the 4 corrections you should apply, 3 or 4 corrections that you should apply for the moon. Okay, so I'm going back to my little diagram now for the moon, and I will explain this to you once again. So you started from your sextant altitude, you have an index error which gives you the observed altitude, and you have the dip that transforms HO into HA, and then you have part 1, part 2 with a horizontal parallax, maybe the 30 minutes for the upper limb to be subtracted, and then maybe a correction optionally for non-standard atmospherical conditions, and this gives you then again your through altitude, okay, which you compare to HC, and which will give you a positive or negative intercept. Okay, voilà. So I hope this is clear, all clear to you now. But again, should you have any questions, do not hesitate to ask them in the discussion forum or during the next online session. Okay, good luck.